Hello, and welcome to Algeomelis Prep Academy. Our lesson for today is related rates application problems, more specifically with cones and cylinders. Before we get in, here are some important formulas we must know. Example 1. A cylindrical glass with radius 5 cm is being filled with water at a rate of 3 cm cubed per minute. How fast is the height of the water increasing? We can then plug in our values for r, which is 5 squared, which allows us to get an equation of volume is equal to 25 pi h. We must then find the derivative. From here, we can then plug in dv dt. dv dt is given in the problem to be 3 cm cubed per minute, allowing our equation to be 3 is equal to 25 pi dh dt. Doing some simple algebra, we get 3 over 25 pi is equal to dh dt. And furthermore, simplifying this gets us dh dt is equal or approximately 0.0382 centimeters per minute. Our second problem is a cone-shaped paper cup is being filled with water. However, it has a small hole at the bottom tip and it is dripping at a rate of 2 centimeters squared per second. The height of the cup is 12 centimeters and the diameter of the top of the cup is 8 centimeters. How fast is the level of the water decreasing when the depth of the water in the cup is 4 centimeters? Drawing a diagram, we can draw the cone upside down given a diameter and height. D from the problem is 8 centimeters and H is 12 centimeters. dv dt is negative 2 centimeters cubed per second as the water is dripping out of the cone. Our formula for volume will be 1/3 pi r squared h, and when h is equal to 4 centimeters, we need to find what dh dt is. We can then use our basic volume equation of 1/3 pi r squared h in order to find the radius using proportions. We can set up the proportion using 2r is equal to the diameter, and the diameter of the problem is 8. Therefore, our radius is 4 centimeters. We can then set up the entire proportion as 4 over 12 is equal to radius over h. Then using some simple algebra, we get that r is equal to h over 3. Our formula for volume is v is equal to 1/3 pi r squared h, and creating a proportion, we can get that r is equal to h over 3. We can then plug in r into our original equation, and simplifying the equation, we get v is equal to 1/3 pi 1/9 times h squared times h. That leaves us with v is equal to 1 over 27 pi h cubed. We then need to find the derivative of our equation. Simplifying our equation, we get that dv dt is equal to 1/9 pi h squared dh dt. And we can then plug in our given values. We get that dh dt is equal to 9 over 8 pi, or negative 0.35801. This can be simplified to negative 0.358 centimeters per second. Our third problem will be a machine is dropping dirt on a conical pile. Its height is 1/2 the radius of the base, and the height is increasing at 2 feet per second. Find the rate of change of the volume when the height is 4 feet. Drawing a diagram, labeling h and r, we can use the simple volume formula and our given values in order to find dv dt in feet cubed per second. We then need to find the derivative of our basic volume equation, and simplifying the equation, we can then plug in our given values. We can then set up a proportion with h, making h equal to r over 2, and simplifying the equation, we can get that 2 is equal to 1/2 dr dt. That would give us dr dt is equal to 4 feet per second. Using our proportion we previously made, we can then solve and find that r is equal to 8 feet. Next, we can find the equation we previously made and plug in our given values we found previously. Using simple algebra, we come to a value of dv dt being 402.1238597 feet cubed per second. That was related rates, cones, and cylinder problems from Algeriano's Prep Academy. Thank you for watching. Make sure to like and subscribe.